Hello and welcome to this webinar this afternoon or today. For the people who don't know me, I'm Hervé Baour. I'm taking care about the international markets, and I welcome you here in Van Lancourt. Today we're gonna talk about the PCD cutting tools. So we're gonna have a look of what can be done, what are in stock and standard from our warehouse, as well as what's next in the future and what you could expect from us in the coming weeks or months. These last years, we have seen a lot of inquiries about PCD, and as it was before really expensive, the people didn't really look at these tools that much. However, the advances in technology, as well as in grinding possibilities, led us to decrease the price, as well as enhancing the capabilities, the performances of these cutters. You can definitely ask questions on the QR section of your bottom of your screen, and also, as always, I will ask you some questions or some polls to know more about what your needs and what can be done in terms of going in the right direction for your dedicated needs. If you have a production in hard to machine material like platinum, gold, brass, and more true for lead-free brass, we gonna cover these different materials, and you are at the right place here. So as said before, our idea with this webinar is to present you what we do have in stock and standard, and what can be done with our grinding possibilities. So as said, we will have some polls or questionnaire. So I'm gonna open the first one in order to better know your expectations. So for which operation did you already use PCD cutters? So I leave you some seconds to answer to this one. So we first need to understand what is really PCD. So let me share my PowerPoint presentation. So PCD is diamond, but diamond can be found in different form, different shapes. So here you see a monocrystal diamond. This is used. You have two types of monocrystal diamond. You have the natural one and the synthetic one. The natural one can be found on jewelry, for instance, on rings also, as well as some diamond polishing tool, the same as synthetic monocrystal diamond, so-called MCD. In our production, we don't have this possibility because it's a lot of know-how that we don't really have in-house right now. The second option to get diamond on cutters is to have coating. Diamond coating is put over usually carbide cutters. So we do have this in-house. We can do that in-house, but it's not the main concern of this webinar. The webinar will talk about PCD. So the PCD is some powder that is sintered onto carbide plates or substrate, and this is grown directly onto the carbide. Then this carbide is cut, as you can see on the bottom right picture, and these parts of PCD based on carbide will be soldered or welded on our case carbide bar. And we're gonna use this PCD in various conditions. To have an idea on the PCD itself compared to standard carbide cutters, we can say, or we can a rule of thumb will give you a life duration of 10 times more than a carbide cutter. So it's quite interesting. Even if the PCD cutter costs 10 times more than a carbide, which is not the case, but if it would, it's still interesting because obviously you don't have uh, the machine which is down to change the cutter and do the setup again on the machine. So it's if you have a large production series, then it's really interesting to go with the PCD. Of course, it does have a drawback because diamond is carbide or carbon, excuse me. It cannot cut ferrous material. So the PCD is only available or machine can only machine non-ferrous material. Which leads me to the second poll, asking you which material would you be interested to use PCD cutters? So I share my screen again to go on the next slide. So, and here we do have actually a view, a table with the different materials that can be machined with PCD cutters. So you can find the different material, but we will focus on several. Maybe if we go on the left-hand side, the left column, we do have silver, bronze, gold, but platinum. Platinum is kind of really hard material to machine, really abrasive. And the even for small series, the PCD is the best way. And I would say on the commercial or financial point of view is the optimal material or cutters to work with. Also, the gold is well machined with the PCD. Should it be yellow, pink, or white? So all the type of golds are well machined with the PCD. If we go on the middle column, so we see copper, brass, and you might be faced of machining lead-free brass. Lead-free is not so easy to machine, lead-free brass. So PCD helps you a lot in this direction. So as the beryllium copper, also called the QB as short. Aluminum is also a material that is well machined with PCD. Of course, you cannot. Well, it depends on of what you want to reach, but you cannot have a diamond polished face with a PCD. It's really fine. It's the roughness of the surface is really low, but you don't have a mirror finish as you would have, excuse me, with a diamond monocrystal MCD cutter. But you reach really good surface state with PCD. And then if we go on the right column, more and more composite materials filled with carbon fibers or glass fibers are appearing in order to extend the strength of the material itself or to have a light platform. So PCD is working really well on all or a lot of this kind of composite materials. And what I will show here as well is a video that our friend from Switzerland, the company Bumotech Starag, made on Bumotech S100 Multi. So you will see a 4015 cutter. So it's an end mill with a diameter of 6. So the 15 gives you the cutting length, which is 1.5 D. So you have a cutting length of 9 millimeter. The speed is quite impressive with the spindle speed of 53,000 RPM. Usually here they took a VC of 1,000. Usually we recommend something like 500, but the machine is really rigid and really performant. So they could make it with 1,000 meters per minute. And I will show you the video. So you can imagine the speed of the cutter. So it's a PCD 2 teeth cutter that is working amazingly. Really impressive, isn't it? This is possible so with on a really rigid machine, as I mentioned before. And what to know also is about the cutting parameters. So for the brass, as I previously said, the cutting speed should be rather on the 500 meters per minute. For gold, we are somewhere around 300, and platinum 150 meters per minute. Talking about the AP and AE, so you better go fast, but not deep. So you better have a ramp or a plunging into the material interpolation. Excuse me, a helical interpolation to make the hole, and then go fast on the side, well, on basically on the full cutting length. This is giving you the best performance with this kind of cutters. Um, Also, it's really important to on the feed not to go below a 2.5 micrometers per teeth. So I really to give the material to the cutter. Of course, for each and every application you do have in-house, you always can call us in order to ask us the cutting parameters. Let me go back on the presentation. Here you see the different way of grinding we do have at Louis Bélet. You might have seen that several PCD suppliers, but I can really tell you that at Louis Bélet we are using only the finest material on PCD, so the finest grain of diamond, which allows us to have a perfect cutting edge, even with the grinding wheel that you see on the right hand side of your screen. What we cannot do with the grinding wheel, because it's diamond on the wheel as well on the cutter, is to cut the diamond. So you remove the with the wheel, you do remove the little grains. So you have a maybe less fine cutting edge, but as the grain is so small, the cutting edge is really, I mean, really sharp. And you can see also the edge radius, which is something like 3.5 micrometer, which is the main or what we can achieve with the grinding wheel. On the opposite, on the left-hand side, we do have the laser grinding, and this is the only way we found today to cut really the diamond grain. So you have a perfect sharp edge. And here you can achieve a radius of 2.5 micrometers. So you see we are on the same range, but still the sharpness of the cutter would be a little bit better with laser. We do have some limitation, should it be on the laser or on the grinding wheel, but with the laser, it allows us to really have a different shape that you cannot have with the grinding wheel. So we now come onto our portfolio of PCD cutters. So it goes. You can see that it's rather on the lower in terms of dimension. So we have drills, which are going from 0.48 to 2.5 millimeters standard. So we have a stock in our warehouse. Then to the end mill, so ball end mill reference 4200 from 1 to 12 millimeter. End mills with different cutting lengths. The 10 is a 1D, the 15 is the 1.5D and 22 times D. We also have T cutters with reference 4100 with a diameter from 3 to 16 and a width of 0.6 to 6 millimeter. We go on with engraving mills, the 4119-3 with various angles from 40 to 90 degrees. Pointer of 90 degrees with a 4120. Whirling tools, which is working outstandingly. The 45-600, I come back in a sec like with this, and Fred cutting tools, the 45-200. I come back on the wording too, because as you can see on the picture, the black part is the PCD. And here you see the black part, which is, I mean, the complete part of the front of the cutter. That means that it's really a solid state PCD cutter. So that means that you have all the PCD, all the teeth. So for instance, this one you do see here is a 3-teeth S0.6 whirling cutter. So you really have a top of the class cutting tool here. But of course, you know us, and you know that we are really strong in custom cutters. So you see here a port of some examples of cutters we did for some customers, and which are custom basically. So we are not really well known on inserts. We do not do our own inserts, but we can do any type of inserts which are shape inserts, also with chip breaker. So don't hesitate to challenge us. We do have a lot of experience in chip breaking devices, and also if you have a different various shape, we can produce that also in series. So like the bowing bars you do see a bottom right, slitting saws, pointers, etc., etc. And I will show you here an example of cutter we do have. So I will show you two cutters. The first one is a step drill, two-tip step drill with a diameter of 1.5. So you see here the sharpness of the edge, the precision between the two teeth. You also do see the small holes that allows us to have really a sharp edge. Here again, so all this is PCD. This is really important. And you also see the angle, the tip angle that was defined, and it is really constant between the two flutes. And also on the tip, you are really really sure that that it doesn't have a run out on the top. So this was for the step drill, and the second tool is an end mill, two-teeth end mill, and the diameter of that end mill is 1 millimeter. So here as well you have two teeth. I think it was it's a 1.5D, so a length of 1.5 millimeter, and two teeth end mill of 1 millimeter, and the two teeth are really in PCD. What also is new, or will come and more is that we can offer cutters with coolant through. So we cannot have the coolant through directly on the PCD itself, but we can accompany or drive the coolant really on the cutting area. So you understood that we are really on the development, and the next big thing will be helix fluted cutters. So not only the drills as we do have today, but all or most of our cutters will be able to be produced in helix with a helix flute. Today, we are in development with an end mill diameter 0.7 with a Z3. So it's becoming really interesting and really mad in the development of such cutters, and all this with a helix flute. So stay tuned. I'm sure you will like what we will have to what we will be able to show you. I come back on the presentation, and what I wanted also to show you here is development that we are also doing that will come live really shortly in weeks from now. It's carbide cutters with a diamond coating, really really thick diamond coating, but after then sharpen with the laser. So you see there is a lot of development going on, and I'm sure you will like this kind of cutters. And let me open the last question that we are interested in, and we would like to know from you which type of PCD cutter you would like to see as a helix fluted cutters. Um, while you are answering this poll, let me tell you that we are developing a new version of our PCD drill, and yeah, I'm sure you will like it. It will be more precise and more performant. I will go on with the presentation. I'm reaching to the end of it. What I wanted to share with you is some success stories. So here you see the 45 600 whirling tool. We had a customer which was doing so inside the whirling with a SO6 on a length of 1.2 millimeter in beryllium copper. And with a traditional whirling tool, one teeth, he reached about 50 pieces with a free teeth. So he could reach 250, but he was not still satisfied. And finally, we did this cutter in PCD. And he could reach 12,000 so with whirlings into the beryllium copper, and this was outstanding because he didn't even went to the end of the life duration of this cutter, because the series of what he had to do was 12,000. So we really were at like new standpoint on the cutting edges. So a real and nice success story. The next one is about engraving mill. So, and at a watch manufacturer, this customer had to do some engraving, both in gold and platinum, with standard engraving mills in carbide. He had a consumption of something like 3,000 engraving mills a year. So, and there were a lot of control, because the life duration was not similar to each other. So he always had to check and measure the parts, so his production. And he switched to the PCD, and he only had to make the control once in the morning and once in the evening. And he's consuming something like 100 to 200 end mills a year, so 30 times less than with engraving mill. So in carbide. So really, it's a big plus and a big step for our customer to use PCD cutters. All right, so I think I made the tour of the story. What I propose you now is to open the question session, and I see we do have some question already, but while you are writing your question, if you do have, I will also share with you the polls that we had. Asking you for which operation did you already use PCD cutters? We had some answer in the milling, turning, and whirling. The second one was in which material would you be interested to use PCD cutters? 25% of the pollies said precious material, 75% brass, 50% lead-free brass, 50% as well beryllium cutter and titanium, and other non-ferrous material, 25%. Quick remark on titanium. Titanium is still under investigation, I would say. Some people are using PCD in titanium and it's working fairly well, but we do have some combination with carbide and coating, which is working not the same, but almost the same as a PCD tool. So our experience, I do not say it doesn't work. I just say that our experience for titanium, cutting geometry, I mean, there's still a lot to do of enhancement on the cutter geometry, combined with the good carbide grade and the good coating. So sure, you can use a PCD in titanium, but we really do have a good solution also as alternatives. Brass and lens-free brass, sure. I mean, these are the main usage of our PCD cutters in the industry. And precious metal, yeah, for as I said at the introduction, platinum. I mean, it's almost the only way to machine correctly platinum with PCD. The third poll was about the which geometry would you like to see as a helix fluted? Not really surprised to see, because we did that webinar in different languages and we had the same answer. And mills, yeah, we are coming really fast on it with our development. So you will see end mills with a helix fluted in PCD really soon on our product portfolio. It's followed by a drill. Yes, drill and step drill. We will have this really fast as well in our catalog. Foam cutter, engraving mill, and T cutter do have some interest, but not as much as the rest. All right, so I open up now the question and answer. Can you make fine pitch hub using PCD for gears made out of high temperature nickel steel? That's a good question. We tried, or we had some inquiries about hub with PCD teeth. It's not trivial, really. I mean, we are on the real fine pitch, as you know, and today we do not propose this. But if you are interested in testing that and you would like us to develop, you are more than welcome to come to us and challenge us, and we can see what can be done. Sure. Second question, can you do any kind of chip breaker on your insert? Oh yeah. I do not have a real or a nice picture, but we really can do any type of chip breaking apparatus in front of the insert. We can do any shape. I will try to put some pictures on the technical information that you will get after this webinar, but really you will be able to get or to have any kind of chip breaking devices. You even can write your logo if you wish, and what's important to note, and I see there is a question on that. We can use any insert type. Should it be BMU or Utilis or Applitech or whatever? So we get or we buy, either you send us or we buy the insert. Then we braze a PCD insert on it, and then we laser grind, or we grind the shape you want together with the chip breaker in front of it. Okay, so I think I made the tour of the question. I do not see any additional question. Let me show you my contact information. Don't hesitate to contact me for any inquiry, always available. And if I'm not, drop me an email. I will be glad to answer to it. Don't forget as well to link us on LinkedIn, or like our company page. It's a growing community where we do also give you many information. Well, yes, I think we make the most of it. I wish you are all in good health. Next webinar will be held certainly in May. Maybe for the topic is not 100% sure, but it should be for composite machining. We will show you our capabilities and what kind of material or cutters we do have. Meanwhile, yes, stay healthy, enjoy everything, take care of yourself and your family, and enjoy machining with Louis Bélet cutting tools. Thank you very much. Bye bye.